Section 13 of Gray's Anatomy, Part 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Anatomy of the Human Body, Part 1, by Henry Gray. The cervical vertebrae, Vertebrae cervicalis. Cervical vertebrae are the smallest of the true vertebrae, and can be readily distinguished from those of the thoracic or lumbar regions by the presence of a foramen in each transverse process. The first, second, and seventh present exceptional features and must be separately described. The following characteristics are common to the remaining four. The body is small and broader from side to side than from before backward. The anterior and posterior surfaces are flattened and of equal depth. The former is placed on a lower level than the latter, and its inferior border is prolonged downward, so as to overlap the upper and forepart of the vertebra below. The upper surface is concave transversely, and presents a projecting lip on either side. The lower surface is concave from before backward, convex from side to side, and presents laterally shallow concavities which receive the corresponding projecting lips of the subjacent vertebra. The pedicles are directed lateralward and backward, and are attached to the body midway between its upper and lower borders, so that the superior vertebral notch is as deep as the inferior, but it is at the same time narrower. The laminae are narrow and thinner above than below. The vertebral foramen is large and of a triangular form. The spinous process is short and bifid, the two divisions being often of unequal size. The superior and inferior articular processes on either side are fused to form an articular pillar, which projects lateralward from the junction of the pedicle and lamina. The articular facets are flat and of an oval form. The superior look backward, upward, and slightly medialward. The inferior forward, downward, and slightly lateralward. The transverse processes are each pierced by the foramen transversarium, which in the upper six vertebrae gives passage to the vertebral artery and vein and a plexus of sympathetic nerves. Each process consists of an anterior and a posterior part. The anterior portion is the homologue of the rib in the thoracic region and is therefore named the costal process or costal element. It arises from the side of the body and is directed lateralward in front of the foramen and ends in a tubercle, the anterior tubercle. The posterior part, the true transverse process, springs from the vertebral arch behind the foramen and is directed forward and lateralward. It ends in a flattened vertical tubercle, the posterior tubercle. These two parts are joined outside the foramen by a bar of bone which exhibits a deep sulcus on its upper surface for the passage of the corresponding spinal nerve. Footnote: the costal element of a cervical vertebra not only includes the portion which springs from the side of the body, but the anterior and posterior tubercles and the bar of bone which connects them. End of footnote. First cervical vertebra. The first cervical vertebra is named the atlas because it supports the globe of the head. Its chief peculiarity is that it has no body, and this is due to the fact that the body of the atlas has fused with that of the next vertebra. Its other peculiarities are that it has no spinous process, is ring-like, and consists of an anterior and a posterior arch and two lateral masses. The anterior arch forms about 1/5 of the ring. Its anterior surface is convex and presents at its center the anterior tubercle for the attachment of the longus colli muscles. Posteriorly it is concave and marked by a smooth oval or circular facet, fovea dentis, for articulation with the odontoid process, dens of the axis. The upper and lower borders respectively give attachment to the anterior atlanto-occipital membrane and the anterior atlantoaxial ligament. The former connects it with the occipital bone above, and the latter with the axis below. The posterior arch forms about 2/5 of the circumference of the ring. It ends behind in the posterior tubercle, which is the rudiment of a spinous process, and gives origin to the recti capitis posterioris minoris. The diminutive size of this process prevents any interference with the movements between the atlas and the skull. The posterior part of the arch presents above and behind a rounded edge for the attachment of the posterior atlanto-occipital membrane, while immediately behind each superior articular process is a groove, sulcus arteriae vertebralis, sometimes converted into a foramen by a delicate bony spiculum which arches backward from the posterior end of the superior articular process. This groove represents the superior vertebral notch and serves for the transmission of the vertebral artery, which after ascending through the foramen in the transverse process winds around the lateral mass in a direction backward and medialward. It also transmits the suboccipital first spinal nerve. On the undersurface of the posterior arch, behind the articular facets, are two shallow grooves, the inferior vertebral notches. The lower border gives attachment to the posterior atlantoaxial ligament, which connects it with the axis. The lateral masses are the most bulky and solid parts of the atlas, in order to support the weight of the head. Each carries two articular facets, a superior and an inferior. The superior facets are of large size, oval, concave, and approach each other in front, but diverge behind. They are directed upward, medialward, and a little backward, each forming a cup for the corresponding condyle of the occipital bone, and are admirably adapted to the nodding movements of the head. Not infrequently they are partially subdivided by indentations which encroach upon their margins. The inferior articular facets are circular in form, flattened or slightly convex, and directed downward and medialward, articulating with the axis and permitting the rotary movements of the head. Just below the medial margin of each superior facet is a small tubercle, for the attachment of the transverse atlantal ligament which stretches across the ring of the atlas and divides the vertebral foramen into two unequal parts, the anterior or smaller receiving the odontoid process of the axis, the posterior transmitting the medulla spinalis and its membranes. This part of the vertebral canal is of considerable size, much greater than is required for the accommodation of the medulla spinalis, and hence lateral displacement of the atlas may occur without compression of this structure. The transverse processes are large. They project lateralward and downward from the lateral masses, and serve for the attachment of muscles which assist in rotating the head. They are long, and their anterior and posterior tubercles are fused into one mass. The foramen transversarium is directed from below, upward, and backward. Second cervical vertebra. The second cervical vertebra is named the epistrophius or axis because it forms the pivot upon which the first vertebra, carrying the head, rotates. The most distinctive characteristic of this bone is the strong odontoid process which rises perpendicularly from the upper surface of the body. The body is deeper in front than behind, and prolonged downward anteriorly so as to overlap the upper and fore part of the third vertebra. It presents in front a median longitudinal ridge separating two lateral depressions for the attachment of the longus colli muscles. Its undersurface is concave from before backward and convex from side to side. The dens or odontoid process exhibits a slight constriction or neck where it joins the body. On its anterior surface is an oval or nearly circular facet for articulation with that on the anterior arch of the atlas. On the back of the neck and frequently extending onto its lateral surfaces is a shallow groove for the transverse atlantal ligament which retains the process in position. The apex is pointed and gives attachment to the apical odontoid ligament. Below the apex the process is somewhat enlarged and presents on either side a rough impression for the attachment of the alar ligament. These ligaments connect the process to the occipital bone. The internal structure of the odontoid process is more compact than that of the body. The pedicles are broad and strong, especially in front, where they coalesce with the sides of the body and the root of the odontoid process. They are covered above by the superior articular surfaces. The laminae are thick and strong, and the vertebral foramen large, but smaller than that of the atlas. The transverse processes are very small, and each ends in a single tubercle. Each is perforated by the foramen transversarium, which is directed obliquely upward and lateralward. The superior articular surfaces are round, slightly convex, directed upward and lateralward, and are supported on the body, pedicles, and transverse processes. The inferior articular surfaces have the same direction as those of the other cervical vertebrae. The superior vertebral notches are very shallow and lie behind the articular processes. The inferior lie in front of the articular processes, as in the other cervical vertebrae. The spinous process is large, very strong, deeply channeled on its under surface, and presents a bifid, tuberculated extremity. The seventh cervical vertebra. The most distinct characteristic of this vertebra is the existence of a long and prominent spinous process, hence the name vertebra prominens. This process is thick, nearly horizontal in direction, not bifurcated, but terminating in a tubercle into which the lower end of the ligamentum nuchae is attached. The transverse processes are of considerable size, their posterior roots are large and prominent, while the anterior are small and faintly marked. The upper surface of each has usually a shallow sulcus for the eighth spinal nerve, and its extremity seldom presents more than a trace of bifurcation. The foramen transversarium may be as large as that in the other cervical vertebrae, but is generally smaller on one or both sides. Occasionally it is double, sometimes it is absent. On the left side it occasionally gives passage to the vertebral artery. More frequently the vertebral vein traverses it on both sides, but the usual arrangement is for both artery and vein to pass in front of the transverse process and not through the foramen. Sometimes the anterior root of the transverse process attains a large size and exists as a separate bone, which is known as a cervical rib. End of section 13.